Quarter 1, Module 9, Lesson 1. Determine the equation of a quadratic function. Objectives. Determine the equation of a quadratic function given zeros, a table of values, and graph. To determine the equation of a quadratic function given its zeros or roots, follow these steps. Derive the factors from the given roots. Multiply the factors and then equate the product of the factors to y or f of x. Example number 1. Find a function whose zeros are 5 and -1. If you remember in the previous lesson, we solved the zeros of the function by letting y equal to x, equating each factor to 0, then solve for x. This time, we will do the reverse operation. Given the zeros of the function, we will find the equation. Solution: x is equal to 5. To find the factor, subtract 5 from both sides. And you will get x minus 5 is equal to 0. On the other hand, x is equal to -1. Add 1 to both sides to make the right side equal to 0. So we will have x plus 1 is equal to 0. Now multiply the factors. X times x, x squared, x times 1, 1x, -5 times x, -5x, -5 times 1, -5. Combine like terms, -5x plus x is -4x. So the equation whose zeros are 5 and -1 is y is equal to x squared minus 4x minus 5. Example number 2. Find the function whose zeros are 8 and 9. X is equal to 8. Subtract 8 from both sides. So x minus 8 is equal to 8 minus 8, and that is 0. So the factor is x minus 8. On the other hand, x is equal to 9. Subtract 9 from both sides, and you will get x minus 9 is equal to 0. Multiply the factors. Since the value of each factor is 0, when you multiply them, 0 times 0, you will get 0. X times x, x squared. X times -9, -9x. -8 times -9, positive 72. -8x plus -9x is -17x. So the equation is y is equal to x squared minus 17x plus 72. Or the function is f of x is equal to x squared minus 17x plus 72. Example number 3. Find the function whose zeros are 3/2 and -4. X is equal to 3/2. Multiply both sides by 2. 2x is equal to 3. Subtract 3 from both sides. 2x minus 3 is equal to 3 minus 3, which is 0. X is equal to -4. Add 4 to both sides. X plus 4 is equal to -4 plus 4, or 0. Multiply the factors and equate it to 0. 2x times x, 2x squared. 2x times 4, 8x. Negative 3 times x, negative 3x. And negative 3 times 4, negative 12. Combine like terms, 8x plus negative 3x is 5x. So the function is f of x is equal to 2x squared plus 5x minus 12. Now let us determine the equation of quadratic function given its graph. Here are the steps. Identify the vertex. Find A by substituting any point to the vertex form. F of x is equal to A times the square of x minus h plus k. Substitute the vertex and A to the vertex form of quadratic equation. Example number 4. In the graph at the right, the vertex has coordinates negative 5 and 6. Let us choose any point. Example, negative 3, 10. Substitute these values to the vertex form of quadratic equation to solve for A. H is negative 5, K is 6, X is negative 3, and Y is 10. Negative 3 minus negative 5 is negative 3 plus 5, and that is 2. The square of 2 is 4, so it is 4a. Subtract 6 from both sides. 10 minus 6 is equal to 4a plus 6 minus 6. So 4 is equal to 4a. Divide both sides by 4. So a is equal to 1. Derive the equation by substituting the vertex and a. A is 1, h is negative 5, k is 6. X minus negative 5 is x plus 5. So the equation is y is equal to the square of x plus 5 plus 6. You can check your answer through substitution. And the left should be equal to the right. Example number 5. In the graph at the right, the vertex is 7, negative 9. Let us choose the point 11, negative 1. Substitute the values. H is 7, K is negative 9, X is 11, Y is negative 1. 11 minus 7 is 4. The square of 4 is 16. 16 times A minus 9 is equal to negative 1. To solve for A, isolate 16A by adding 9 to both sides. Negative 9 plus 9 is 0. And negative 1 plus 9 is 8. So 16A is equal to 8. Divide both sides by 16. So A is 1/2. Substitute A and the vertex. So the function is f of x is equal to 1/2 of the square of x minus 7 plus negative 9. To determine the equation of a quadratic function given the table of values, follow these steps. Choose any 3 points from the table of values. Substitute each point to the standard form of quadratic equation to come up with 3 linear equations. Then solve for A, B, and C. Substitute the A, B, and C to the standard form of quadratic equation. Example number 6. Derive the equation of the quadratic function whose sum points are in the table of values below. I will choose 0, 30, 1, 12, and 2, negative 2 because the other 2 points have bigger values of y, 78 and 52. It's easier to substitute smaller values. Let us use 0, 30. Substitute 0 to x and 30 to y. And we will get 30 is equal to the square of 0 times a plus b times 0 plus c. So the equation number 1 will be 30 is equal to c. Let us use 112 where x is 1 and y is 12. Substitute these values to the equation and we will get 12 is equal to a times the square of 1 plus b times 1 plus c. So the second equation is 12 is equal to a plus b plus c. And last, in point 2, negative 2, we will get negative 2 is equal to the square of 2 times a plus b times 2 plus c. 2 squared is 4. So the third equation is negative 2 is equal to 4a plus 2b plus c. Substitute the equation 1 to equation 2 and 3 since equation 1 is the simplest. Equation 1 is c is equal to 30. So equation 2 will be 12 is equal to a plus b plus 30. Equation 3 will be negative 2 is equal to 4a plus 2b plus 30. Multiply equation 2 by negative 2 so that when we add equation 2 and 3, b will be eliminated. 12 times negative 2 is negative 24. A times negative 2 is negative 2a. B times negative 2 is negative 2b. And 30 times negative 2 is negative 60. Negative 24 plus negative 2 is negative 26. Negative 2a plus 4a is 2a. Negative 2b plus 2b is 0b or 0. And negative 60 plus 30 is negative 30. So the new equation will be negative 26 is equal to 2a plus negative 30. Now to solve for a, add 30 to both sides. Negative 26 plus 30 is 4. And negative 30 plus 30 is 0. So we will just have 2a at the right side. Divide both sides by 2. So a is 2. Now substitute a and c to one of the equations to get the value of b. Let us use equation 2 because it's more simple compared to equation number 3. 12 is equal to a plus b plus c. Substitute 2 to a and 30 to c. 2 plus 30 is 32. To solve b, subtract 32 from both sides or add negative 32 to both sides. 32 plus negative 32 is 0 and 12 plus negative 32 is negative 20 and that is our b. Now we have values of a, b, and c, so we can have the quadratic equation. y is equal to 2x squared minus 20x plus 30. You can check the equation if it is correct by substituting some points, like negative 278. Substitute negative 2 to x and 78 to y. The square of negative 2 is 4. 4 times 2 is 8. Negative 20 times negative 2 is 40. 8 plus 40 plus 30 is 78. So it's correct. You can also try negative 1, 52, 0, 30, and still the equation is true to these points. Example number 7. Derive the equation of the quadratic function whose some points are on the table of values below. Let us try other method. We will only use 2 points to have 2 equations because we will use the formula for A, which is the second difference of y divided by 2. 5 minus negative 6 is 11. 22 minus 5 is 17. 45 minus 22 is 23. And 74 minus 45 is 29. So these are the first differences. Now let's get the second difference. 17 minus 11, 6. 23 minus 17, 6. And 29 minus 23 is 6. Using the formula, we will get A is equal to 6 divided by 2 is equal to 3. Let us now use any 2 points. I chose point whose coordinates are 1 and negative 6. Substitute 1 to x and negative 6 to y. So the equation 1 will be negative 6 is equal to A plus B plus C. Let us use point with coordinates 2, 5, where x is 2, y is 5. Substitute to the equation. 2 squared is 4. So we will have 5 is equal to 4a plus 2b plus c as our equation number 2. Now that we already have a, substitute it to the equations 1 and 2. Equation 1 will be negative 6 is equal to 3 plus b plus c. And equation 2 will be 5 is equal to 12 plus 2b plus c. Multiply equation 1 by negative 1 so that when we add equation 1 and 2, c will be eliminated. Negative 6 is equal to 3 plus b plus c. Multiply both sides by negative 1 and we will have 6 is equal to negative 3 plus negative b plus negative c. Now add equation 2, that is 5 is equal to 12 plus 2b plus c. 6 plus 5, 11. Negative 3 plus 12, 9. Negative b plus 2b is 1b. Negative c plus c is 0. To solve for b, isolate it by adding negative 9 to both sides. Negative 9 plus 9 is 0. And 11 plus negative 9 is 2. Now substitute a and b to one of the equations to get the value of c. Let us use equation 1 because it's more simple. Negative c is equal to a plus b plus c. Substitute 3 to a and 2 to b. Negative 6 is equal to 3 plus 2 plus c. 3 plus 2 is 5. Subtract 5 from both sides or add negative 5 to both sides so that we will get c. 5 plus negative 5 is 0. And negative 6 plus negative 5 is negative 11. So that is our C. Substitute 3, 2, and negative 11 to the standard form y is equal to ax squared plus bx plus c. And we will get y is equal to 3x squared plus 2x minus 11. You can check your understanding by answering these activities. Thank you.